Okay, we are getting ready to start Module 1, Lesson 5, which is 2.3, and we're going to talk about subtracting integers. So if we look at number 1 as we fill in these blanks, it is true that a minus b equals, and what they want you to realize is that whenever you subtract, for example, if I'm subtracting 4 minus 1, that's 3, and if I add a negative, that's a plus sign, sorry, it's hard to write neatly, obviously. They just want you to realize when you add a negative, it's the same thing as subtracting. 4 minus 1 is 3. 4 plus a negative 1 is also 3. Number 2, to evaluate this expression x minus y, x equals negative 10 and y is negative 14, what is that going to be when we evaluate it? So when I go evaluate that expression, I'm going to go through and put parentheses every time I see a letter. Instead of x, I'm plugging in negative 10, and instead of y, I'm plugging in negative 14. And so you can see what this is negative 10 minus a negative 14, and which one looks like that? D, this one. So objective 1, we're going to talk about how to find the opposite of a number. So the opposite of 3 is negative 3. The opposite of negative 6 is 6. So you notice opposites are the same digit, just the sign is opposite. So another way to think of it is just remember this symbol. I don't care whether you call that a minus sign, a negative sign, a subtract sign. It means the opposite of a number. So like example number 1, if they want me to find the opposite of 9, what that means is I just go put this symbol in front of whatever digit they give me. And yeah, 9 and negative 9 are opposites. So here, as I look at example 2, well, the opposite of negative 15, we understand that it does mean to just change the sign. But I want you to keep in mind, especially as we go through this lesson, that the opposite means I'm going to put this symbol in front of whatever they give me. And they gave me a negative 15. So keep in mind here, 2 negatives in a row mean a positive. That's why that's a positive 15, right? Then for example number 3, the opposite of 0 is 0. There, 0 isn't positive or negative, 0 is just 0. So objective number 2, we're going to talk about subtracting integers, and these rules should look familiar to you because they're the exact same rules as when we added integers. So keep in mind, when we add and subtract integers, we're going to think same sign or different signs. Well, if they're different signs, we're going to subtract, keep the sign of the larger, and if they're the same sign, we're going to add and keep the sign. So look at example 4 for me. Notice it says negative 6 minus 4. If I ask you same sign or different signs, what would you tell me? I know a lot of people get confused by this, but remember, we've already talked about this symbol means the opposite of a number. So if I just look directly in front of each number, do you notice you see the same symbol? So we are going to call them same sign. You see the same thing in front. So same sign, so what are we thinking? We add, so think 6 and 4, add them together, and then keep the sign. And if you think about it, if I go spend $6 and then I go spend $4, I'm going to be in the hole $10. What I want you to realize, let's go ahead and talk about example 5. So this is example 5 is what we did in the last section, 2.2. So if you notice here, if I ask you same sign or different sign, look directly in front of the numbers. You'll see the exact same thing in front of each number, right? So same sign, so we're thinking add, keep the sign. And think about it. If I go spend $6 and then I go spend $4, I'm going to be in the hole $10. What I want you to realize is that these two problems are really the same thing. When we subtract, it's the same thing as adding a negative, just like that very first fill-in-the-blank problem we did. Okay? So if you can just kind of learn to get over that, it'll just help you as we go through this. So example 6, negative 3 minus 5. If I ask you same sign or different sign, look directly in front. You see the same thing. I don't care whether you call it a minus, a subtract, a negative. You see the same symbol. So in that case, we're going to add, keep the sign. Check out example 7, 4 minus 9. Same sign or different signs. This time, they are different, right? Because what you see directly in front is not the same thing. 4 is a positive. 9, that minus sign, is a different sign than what 4 has. So they are different. So what we're thinking is subtract. Keep the sign of the larger. 9 is larger. What do you see in front of 9? A negative. So let's think about this. If I had $4 and I go spend 9, I'm going to be in the hole $5, right? Which is what -5 means. Okay, example 8, 1 minus 8, same sign or different? Different, right? So we're going to subtract, keep the sign of the larger. Okay, check out example 9, 15 minus 10, same sign or different? Different. So subtract, keep the sign of the larger. 15 is larger than 10. What's in front of 15? A positive. Okay, check out number 10. Remember, we've talked about this. This symbol really just means the opposite of a number. So if I ask you what's the opposite of -2, well, the opposite of a -2 is a +2. That's why, again, you will see instructors tell you two signs in a row mean two negative signs in a row mean a positive. So clean that up, rewrite it, because that's what that means. Two negative signs mean a plus sign. And then 10 plus 2, now ask yourself same sign or different signs. Same, so add, keep the sign. Same thing with number 11. -3, there's not two negative signs there, so don't just rewrite that one. But there we notice there's two negative signs. We know the opposite of a -5 is 5. That's why we can clean that up and put -3 plus 5. Now ask yourself same sign, different signs. Different, subtract, keep the sign of the larger. Okay, objective 3, add and subtract integers. So now there may be more than two numbers to add and subtract. Just take two at a time and work it left to right. So here, if you saw -1 minus 11, same sign or different? Same. So add, keep the sign. Bring down what I haven't used yet. I haven't used that -12. And now ask yourself, same sign or different sign? Same sign. So add, keep the sign. Okay, example 13. Here, again, before I even start, I'm going to go ahead and clean that up right there. I know two negative signs in a row mean a positive. So here, let me rewrite that. -8 plus 1 plus a -7. Now take it two at a time. So -8 plus 1, different signs, so subtract, keep the sign of the larger. Go ahead and bring down what I haven't used yet. Same sign or different signs? Different. So I'm going to add, keep the sign. Objective 4, evaluate an algebraic expression by subtracting. So here we're going to evaluate each expression. So here the expression they give me is x minus y, and they tell me instead of x I'm going to plug in -2, instead of y I'm going to plug in 4. So I'm going to go through my expression and put parentheses every time I come to a letter. Instead of x I'm plugging in -2, instead of y I'm plugging in 4. Notice there's not two negative signs to clean up or anything, so if you wanted to rewrite this -2 minus 4, that means the same thing, it doesn't matter. Same sign or different? Same. Add, keep the sign. Okay, looking at the next one. Sorry, let me switch colors here. And then it won't go back. There we go. Okay, so I'm going to go through, evaluate x minus y. I'm going to put parentheses every time I see a letter. Instead of x, I'm plugging in 20. Instead of y, I'm plugging in -7. So now, let's go ahead and clean that up. I know really that means a +7. And so as I think, well, 20 plus 7 is 27. Moving right along. Number 17. Evaluate 3x minus y. So I'm going to go through, and every time I come to a letter, put parentheses. Instead of x, I'm plugging in 1. Instead of y, I'm plugging in -2. So here, we can go ahead and multiply first. 3 times 1 is 3. And in the same step, if you want to go ahead and clean that up, because remember that means a +2. And we know 3 plus 2 is 5. If that was too much in one step, you can go ahead and break it up and change that to a plus sign first and then multiply. Objective 5, solve problems by subtracting integers. Translate the following phrase, then simplify. So find the difference of -2 or -12 and 2. So first of all, you have to know what this word difference means. Remember, difference means to subtract. So they're just telling you to go subtract the two numbers given. So if I subtract the two numbers given, same sign or different sign? Same. So add, keep the sign. Okay, number 19, find the difference, and here's where it gets tricky. Find the difference. So again, I'm going to subtract these two numbers. So if I subtract these two numbers, do you notice I'm subtracting two negative numbers? That's why there's two negative signs right here in a row. And we know that really means to add, right? So clean that up. Then ask yourself, same sign or different? Different. So subtract, keep the sign of the larger. Okay, let's try number 20. Subtract 4 from 10. Again, it's tricky. Subtract 4 from 10 is really this, right? Subtract 4 from 10. Notice when you use subtract from, you will write it in the opposite order that you read it, so be careful. And then 10 minus 4 is 6. 21, subtract negative 3 from 12. So we just talked about in number 20 how subtract from, you'll write it in the opposite order you read it. So subtract negative 3 from, I'm subtracting that number from 12, right? Do you notice I have two negative signs here in a row? So really that means 12 plus 3, which is 15. And yes, that one is tricky. That's why I definitely want to talk about it. Okay, last page. Directions. Translate the following phrase to an algebraic expression. They want us to use x to represent a number. So what that's saying in math, that's where the letter comes in. When we don't know what something is, we just call it a letter name just because I don't have anything else to call it. For example, in 22, the sum of negative 10 and a number. So if they want me to write this as an expression, first of all, expressions don't have equal signs, so no equal signs here. But we need to know what this word sum means. Remember, the word sum means to add, right? So if they want me to go add negative 10 and something I don't know, wouldn't that just be negative 10 added to something I don't know? Okay, x is the thing I don't know. 23, and be careful because this is that subtract from that we talked about is tricky. So if they want me to subtract a number from negative 17, remember, when we subtract, order matters. So if I don't put this in the right order, I won't get it right. So subtract a number. So I'm subtracting a number from negative 17. So it's got to look like that. Next part, number 24, translate the following phrase to an expression. Use x to represent a number. So here, the highest point in the U.S. is the top of Mount McKinley at a height of 20,320 feet above sea level. The lowest point is Death Valley, which is 282 feet below sea level. How much higher is Mount McKinley than Death Valley? So think about elevation. My highest point, so we'll just draw a lovely little elevation here. Okay, so there's my mountain. Here's Mount McKinley, which is 20,320 feet above sea level, right? So that's like the peak of my mountain. Whereas the lowest point is down here in this valley, right? At 282 feet below sea level, which is negative 282, right? So they want to know how much higher is Mount McKinley. So really what we're doing is subtracting the two, 20,320, subtract a negative 282, because remember this is below sea level. So we know again that really means plus, so 20,320 plus 282. So really I just need to add those together. So let's see, that's going to be 201. Let's see, 5, 6. Hopefully I'm adding this right mentally in my head real quick. So I'm getting 20,602 feet. Double check though, make sure I added that right. It's easy to mess up. Put it on the spot. Okay. And last one, let me switch pens again. Okay, 25. The coldest temperature ever recorded on Earth was negative 129 degrees Fahrenheit in Antarctica. The warmest temperature ever recorded was 134 degrees Fahrenheit in Death Valley, California. That place is hot and below sea level, isn't it? How many degrees warmer is 134 than negative 129? So again, they're really asking the difference, and so you just have to be careful. Like if I just gave you a number line, so here's 0, right? Negative 129 is way over here. 134 is way over here. So you can see how, okay, from here to here is 129, from here to here is 134. So you can see how we're going to have to add the two together. So mathematically what's going on here is we're really finding the difference. But remember, if you're finding the difference of a negative number, remember, what does that mean? That really means to add. So here, if I go add 134 plus 129, if I go do that quick arithmetic, that's going to be a difference of 263 degrees. And that concludes 2.3, subtracting integers.